Well, hello there. Welcome back to another day of online note-taking. Today we're going to talk about fractional exponents. So we've worked a little bit with exponents in the past. We reviewed all of our laws of exponents and we talked about negative exponents. So why not throw in some fractional exponents? So all of you out there with fractophobia, this is going to be a pretty tough lesson for you, but I have confidence that you will do just fine. So when we look at taking the square root of a number, the cubed root of a number, the fourth root, the fifth root, okay, we look at what it means to take the square root of something. If I want to take the square root of 4, it means something that multiplies by itself to end up with a value of 4. So I know that if I asked you to find me the value of the square root of 4, you would indefinitely tell me that the answer is 2. Now, just for fun, let's go to our calculators and type in 4 raised to the 1/2 power. So I'm going to go to my calculator. Oh, look, that's from last unit. Let's get out of there. Okay, and I need to go to a calculator page here. All right, so I'm going to just type in 4 raised to the 1/2 power. Not 44. I know some of you caught that. I'm going to do 1 divided by 2. So this is going to be 4 raised to the 1/2 power. And my answer also happens to be 2. All right, now square root of 6. We know that we cannot take the square root of 6. It's not a perfect square. It can't be simplified. So I'm going to put it in my calculator, and it says that any irrational answers, we're going to round to 3 decimal places. Remember, 3 decimal places would be your thousandths. Okay, so we're going to put in the square root of 6. Okay, now my calculator gives the exact answer, and if yours happens to pop up like that, you can just hit Control Enter, and it'll give you the decimal value. All right, so this looks like a value of 2.449. Now, if you had to take a guess, what do you think 6 raised to the 1/2 power is? Nope, it's not 3. I know some of you said 3. It's not. 6 raised to the 1/2 power. Now, look at that. I'm glad that my calculator just did this because you're going to start to see here that the square root of a number is the same as raising it to the 1/2 power. So again, it's 2.449. So I kind of just revealed the little secret that you're going to learn here. Okay, anytime you raise anything to the 1/2 power, it's the same thing as taking the square root of that number. So the same is going to go for the cubed root of a power. It's the same as raising it to the 1/3. So if I take the cubed root of 7, I'm going to end up with 1.913. And if you check in your calculator, if you raise it to the 1/3 power, you're going to get the same answer. All right, fourth root of 16. Remember, fourth root would be a number multiplied by itself 4 times in order to get 16. So what is that value? Good, too. Now, if you raise it to the 1/4 power, because it's the fourth root and you're raising it to the 1/4 power, you're going to get the same value. So that's also going to be 2. Now, this says the cubed root of 8 squared. So this is really the cubed root of 64. And that turns out to be 4. Now look what I did over here. I raised it to the 2/3 power. So the cubed root of 8 squared happens to be the same as 8 raised to the 2/3 power. All right, now we have the square root of 5 to the 3rd. So let's just review what the index of a square root is. Remember, the index of a square root is 2. So just like the index of a fourth root is 4, the index of a cubed root is 3, the index of a square root is 2. So if I take the square root of 5 cubed, it's the same thing as taking 5 and raising it to the 3/2 power. Happens to be 11.180. Yeah, I just knew that off the top of my head. Okay, fourth root of 12 cubed is the same as if I take 12 and raise it to the 3/4 power, 6.447. If you don't believe me, check in your calculator. All right, so we're starting to see the relationship between raising something to a fractional exponent and taking a root and raising it to a power. Okay, so we looked at all the different patterns there. Now we're going to come up with a general rule. So one of the things that you are going to remember as we go through this, anytime you have a fractional exponent, you are going to remember power over root. Okay, now if I look at, and I remember that it's power over root, whatever's in your numerator is the power that you're going to raise it to. And whatever's in the denominator is the root that you're going to take. So in this case, I would take the c root of a and I would raise it to the b power. Now you can also write it as the c root of a to the b. So it doesn't matter whether you raise it on the inside or raise it on the outside. So if the cubed root of 3 squared is 3 to the n, then we got to figure out what n would be. So in this case, I want to know what is my power and what is my root. All right, well, my power is 2. That's your exponent that it's being raised to. The root is your index value. That's the 5 in this case. So if I wanted to write this with power over root, I would write it as 3 raised to the 2/5 power. Okay, so in this case, n would be 2/5. So the thing that you want to remember is power over root. Anytime you're working with fractional exponents, power over root. All right, let's take a look at b. Now remember, when you take the square root of a number, your index is equal to 2. So therefore, your root is equal to 2. All right, so if I take the square root of x raised to the 7th power, remember, power over root, this is going to be x raised to the 7 over 2. So in this case, our n value would be 7/2. All right, those of you with fractophobia, how are we doing right now? You got a lot of fractions. But you know what the good news is? You'll be able to check these in your calculator. So just relax and enjoy the ride, folks. All right, next one. We have 5 raised to the 2/3 power. Remember, power over root. I know, you're probably getting sick of me saying that already, aren't you? Now, remember, the root is your index value, so that is going to be 3, whereas the power is the exponent it's to be raised to. That's your numerator, that's your 2. Letter D, we have p raised to the 8/9. Power over root. Okay, so the power, the y value in this case, and the root, your x value, okay, power over root, power is going to be your numerator, that's 8. Your root's going to be your denominator, that's your x, so that's going to be your 9. All right. Okay, at this point, if you have any questions, either rewind and rewatch, or make sure you make note of it on your paper and ask during the next class. Now we're going to do all these next ones without our calculator. On your quiz and your test, you're going to be asked to evaluate a number raised to a fractional exponent, and you're going to have to show all of your work. So yes, you can check it in your calculator, okay, but you have to make sure that you understand the whole concept behind it, the power over the root, so that you can show your work and get your full credit. Now, if I take 0.6 and I wanted to make that into a fraction, that's 6/10. So that's 6 over 10. Okay, if I wanted to reduce that, that would reduce to what? Nice, 3/5. So I'm going to take 32 and I'm going to raise it to the 3/5. Okay, when we're working with fractional exponents, it is what over what? Good, power over root. All right. So I am going to take the 5th root of 32 and I'm going to cube it when I get done. So the 5th root of 32, what multiplied by itself 5 times gives you 32? That would be 2, and then we're going to raise that to the 3rd power. So 2 times 2, 4, times 2 more, 8. So if you want to check it in your calculator, you can do 32 raised to the 3/5 power, and it's going to tell you the answer is 8. So on your quiz and your test, as long as you show all this work, so you show that you have it raised to the exponent, then you show your power over root, Okay, so your power was 3, root was 5. You take the root, so I took the fifth root of 2, and then I cubed it and got my final answer. So if you want full credit on those questions, make sure you show all those steps. All right, 27 to the 4/3 power. This is going to be the cubed root of 27, and when we get done taking the cubed root of 27, we're going to raise it to the 4th power. Cubed root of 27. Good, gives you 3. Now raise that to the 4th power. So you're going to multiply 3 by itself 4 times. Okay, end up with 81. Now, we have a fraction, and it's raised to another fraction. It's okay, we can do this. So remember, if you're doing power over root, if it's a 2 for your root value, that means that you're going to take the square root. So we're going to take the square root of 1/9. Don't worry, they're both perfect squares. It'll work out okay. And we're going to raise it to the 3rd power. So if I take the square root of 1 and the square root of 9, I'm going to end up with 1/3. Then we have to cube that. So you're going to cube 1 and you're going to cube 3. So that's going to turn out to be 1/27. Okay, another fraction raised to a fraction. It's okay, we can do this. So the root in this case is 3. So we're going to take the cubed root of 8/125. Well, lucky us, 8 and 125 happen to be perfect cubes. And after we get done taking the cubed root of them, we're going to square them. So the cubed root of 8 is 2, and the cubed root of 125 is 5. And now we're going to square that. So that's 2/5 times 2/5. And that turns out to be 4/25. All right, if you didn't understand those 4, go back, rewind, watch them again. Remember, power over root. That's what I want you to keep telling yourself every time you're working with a fractional exponent. Okay, step it up a notch. Let's make these exponents negative. Remember, if I have a negative exponent, I want to take the reciprocal of whatever's being raised to that negative exponent. So this is now going to become 1/16 to the 1/2 power. If you remember from the first page, we said raising something to the 1/2 was the same thing as taking the square root of it. So now I have 1 over the square root of 16, which turns out to be 1/4. All right, let's take a look at the second one here. Move that to the denominator, make your fractional exponent positive. Remember, power over root. So this is going to be 1 over the cubed root of 27, and then we're going to square that. So the cubed root of 27 is 3, so this is going to be 1/3 squared, which is going to turn out to be 1/9. That's 1/9. Okay, now notice where our negative exponent is. It's in the denominator. So in order to make it positive, we need to move it up to the numerator. So this is going to become 8 raised to the 4/3 power. So I'm going to take the cubed root of 8, and then I'm going to raise it to the 4th power. So the cubed root of 8 is 2, and now we're going to raise 2 to the 4th power. So that turns out to be 16. Okay, now if you have a fraction raised to a negative exponent, if you want to make that negative exponent positive, we're going to take the reciprocal of this fraction. So this is going to become, oh my goodness, what was that noise? I think I just got a new email. Hold on just a minute. I don't know if the rest of you heard that noise, but it popped up on my screen. It popped up in my headphones. It was very loud. It scared me very much. Okay, phew. All right, 16/9. Okay, now, because it's raised to the positive 1/2 power, it's the same thing as taking the square root of 16/9. Those are both perfect squares, so we're just going to take the square root of both of those, and we're going to end up with 4/3. Okay? All right, now, remember all those rules we talked about the other day? The one that I want to talk about specifically is power to a power. So remember we talked about last class, if you have an exponent raised to another exponent, call that power to a power. What do you do with your exponents? Nice, you remembered, you multiply them. So I'm going to multiply 2 and 1/2. So this is really going to be 4 raised to the, well, let's take a look at that. 1/2 times 2, or 2/1, happens to be 2/2, which just happens to be 1. Well, what's anything raised to the first power? Itself. Very good. Okay, I have 2/3 raised to the 3/2. So we're going to multiply these two together. So 2/3 times 3/2. What's the relationship between these two fractions here? They are called, starts with an R, reciprocals. Nice. So this becomes 6/6, which is just 1. So again, we have something raised to the first power. So that's just 27. All right, how about 3 or 3/1 times 1/3? Again, oh, coincidence? Don't think so. Working with reciprocals here, this becomes 3/3, which is just 1. So this is 11 raised. It's really not a coincidence that all of them were raised to the first power. We just came up with another rule, folks. Anytime you raise a power to a power and they happen to be reciprocals, so your exponents here are reciprocals. Okay, anytime they are being raised to reciprocals, it's just going to equal 1. So if I multiply those together, it's just going to be 1. So this is going to be a to the first. So it's just going to give you whatever you're raising. So anytime you have a power to a power and they are reciprocals, you multiply them together, you're just going to end up with 1. Now that's going to come in really handy when we go to solve power equations, because it's going to be one of those inverse operations that you'll be able to do to each side of your equation. All right, folks, there's 2 more pages to the notes, and what we're going to do is when we come into class, we're going to work on those together and get a little more practice with fractional exponents. So I hope you guys enjoyed this little video. 16 minutes of your life, almost 17 here. All right, and I will see you guys in class.